All right, so for today we are on 4.10, which is the vertical line test, so determining whether it's a function or not, and then going over domain and range of those functions. So remember that a function must have one input to only one output. So you plug one thing in and you get one thing out. So determine if each of the following represents a function and then explain your answer. So my x values are always my inputs and my y value is always my output. Okay, so if I plugged in a 1, I get out a -4. If I plug in 2, I get out a 3. If I plugged in 3, I get out a -4. Okay, one input, one output. It doesn't matter if the outputs are the same, that's okay. I just need one input to one and only output. So I have individual inputs, so this is in fact a function. One input gives me one output. Okay, let's look at this second one. Okay, x's are my inputs, y's are my outputs. So I plug in a -4, I get out a 1. I plug in a 3, I get out a 2. I plug in -4 again, and I get out a 3. This cannot happen. These are duplicate inputs, so this is not a function. Okay, this would be like, pretend that my -4 is a piece of bread. Okay, so I put in my bread. Okay, so my -4 represents bread. So I'm putting my bread into the toaster. And this is telling me I'm putting in my bread. This 1 is giving me out my toast, and this 3 is giving me out something different, maybe a banana. Okay, that doesn't make any sense. I can't put bread into my toaster and get out toast and a banana or something completely different. It doesn't work. Okay, so one input means that you get one output. You put in bread, you get out toast. That's a function. Okay, so for number 2, we are going to use the graph of the function y equals f of x to complete the table, estimating when necessary. Does this graph represent a function? Explain your answer. So my x values, I'm given. I don't know my y values. That's what I need to figure out. So my x values, -2. Okay, I'm going to the x-axis here. So -2 is right here. What is my y value at 2? This one's a little hard to see, I think personally, but my y value is 0. I'm going to switch colors so that we can kind of follow along. If I plugged in a -3, so x is -3, x equals -3 on my x-axis, I go all the way down to where I meet the line. It's a little hard to tell, but I meet right here. I go over and I'm at -6. So y equals -6. Then we have x equals 3. So x equals 3. What does y equal? Again, y equals 0. I'm right on my x-axis, so there's nothing really to find there. If x equals 1, x equals 1. I'm going to go up to my line right about here. I go over to find my y, and I'm at 3.5. And for the last one, -1, right here, I go up to my x, or I go up to my line, and I go over to my y, and I would say it's roughly 5. Okay, so I went to my x-axis, found that number that I was looking for, that's my input. I went up to the function or down to the function, I met the function, and then I went over to the y-axis to find that y variable. All right, moving on. Vertical line test. You probably first saw this maybe Math 1. If no vertical line intersects the graph at more than one point, then the graph represents a function. So my vertical line is highlighted right here. That's my vertical line. It only intersects the graph one time. So my actual line represents all of the x values at 1 in this case. And where it crosses the function, that is my input / output. Okay, so if I plugged in a 1, I get out a 1. And if I did this anywhere on the graph, it would still pass the vertical line test. So looking at something that does not pass the vertical line test, again, I draw my line. My line represents my input. My input in this case is x = 4. It crosses the function twice. So meaning that when x = 4, I could get out a 2 or a -2. And in this case, that doesn't make sense. I can't get out 2 numbers for 1 input. So this fails the vertical line test. The graph just has to fail once in order for it not to be a function. Okay. So for number 3, apply the vertical line test to determine if each of the following graphs represents a function. Okay, so if I drew my line here, I don't actually intersect. Okay, I draw my line here, I only intersect once. That's good. If I draw it here, only once. I draw it here, only once. So it looks like it's good. I drew a couple different lines just to verify, and it only crosses once. So yes, this is a function. If I'm looking at B, draw my line here, intersects here. Vertical line, good. Intersects once, okay. Doesn't look like it's going to fail the vertical line test. So this one is a function. Looking at C. I draw a vertical line. This one happens to intersect at every single possible point infinitely many times. This one is an absolute fail. It is not a function. And for the last one, draw my vertical line, and I do happen to cross twice right here. I don't need to do it again. If it fails once, it fails all the time. So if my input was 2, for instance, kind of just like the example, y would equal 2 and -2, which can't happen, so not a function. All right, let's see. Here's some more examples of inputs and outputs. Remember, inputs are my x values, outputs are my y values. Inputs go left and right, outputs go up and down because x's go left and right, y's go up and down. Domain and range, we're going to talk about this because students always seem to struggle with domain and range. The domain of a function is all of the inputs, okay? Domain is my inputs. And remember, we know that inputs are x values. So that means that my domain is all of my x values going from left to right. Okay, and I'll write that down. Okay, and in this case, My line continues on forever, continues on forever. I'm going all the way to the left forever, all the way to the right forever. So goes up forever, and it happens to go left forever. This side goes up and right forever. So if it's going to the left and to the right forever, we can say that this particular function's domain is from negative infinity to positive infinity. It's going on forever. So it's all the x values in the world. Now for my range, range is all of the possible outputs. Range is my outputs. So range is going up and down. Remember, outputs are my y values. Y values go up and down on my graph. So range, outputs, they're my y values, and we go up and down. Now, looking at this graph, we've already identified that it's going up forever. Up forever, up forever. Is it going down forever, or does it hit a bottom? In this case, it hits a bottom. We have a minimum value right here at -4. It's not going any lower than -4. So we're going to say that this particular function's range is from -4 to positive infinity. Okay, we're going all the way from -4 and up, positive infinity. Okay, let's see, number 4. Find the domain and range of each function from its graph or its equation. I personally like finding it from the graph. I think it's so much easier than using the equation. If you want to use the equation, you can, but I prefer the graph. So looking at this, remember, domain is how far left and right our x values go. So I'm looking for left and right. If you need to extend your graph, you definitely can. Okay, so my graph is continuing forever to the left and forever to the right. Okay, let me change colors. Okay, but in the middle here, we have this exponential function, and it's going up forever. It's not going vertical, it's approaching 3. And this one is going down forever, again, approaching 3. And if you remember asymptotes from previous courses where these exponentials are, we have this asymptote right at 3 where our line approaches but never actually hits x equals 3. Okay, so it looks like our domain goes from negative infinity to positive infinity, but not x equals 3. So how we're going to write that is from negative infinity to 3. We're going to use an open bracket or a parenthesis to signify it's not equal to, whereas up here I used this square bracket to signify, oh, it can also equal 4. Okay? Open bracket means it's approaching 3 but not equal to 3. And then another parenthesis, 3 to infinity. So this is saying everything except for 3. Okay, then for my range, we're looking for how far up and down my y values go. Okay, so I've already kind of drawn my lines in here. We go up forever and down forever. So it kind of looks like we're going from negative infinity to positive infinity. But we have another asymptote, and it's right here. My lines are approaching 0, but they never actually hit y equals 0. Okay, so in negative infinity to infinity, but not y equals 0. So for my range, we'll have negative infinity to 0, 0 to infinity. Whew, that was a difficult one. Okay, next one. Kind of a half circle here. So we have our function. You can use the function to find your domain and range. Again, I'm going to use the graph because I think that's a little bit easier. So let's start with our domain. Okay, my x values. So from left to right, how far am I going? Well, it looks like my graph doesn't pass this point. We do have a closed circle here. And we go to the right over here and have another closed circle there. Okay, so my domain from left to right, I'm spanning all this. Okay, so from -4 to +4. Now again, I'm using those square brackets to signify, oh, it can equal that number. So -4 and the 4, those actual points, they are included in my domain. All right, then we have our range. Those are my y values going up and down. So how far up does my graph go? It goes up to here, and it goes down to here. Again, closed circles right there. Okay, so the bottom is 0, and the top is 4. Again, closed brackets because it could also be 0 and 4. And I think number 5 is our last one. So from the graph of the quadratic function, find the domain and range, identify zeros, and locate the vertex. How does the vertex of the parabola help you determine the range? Okay, so domain is from left to right. So this one is from left to right. So I'm going forever to the left, forever to the right. So negative infinity to positive infinity. My range, y values, how far up and down I go. I'm going down forever. And my maximum point is 5. So from negative infinity all the way up to 5. For my zeros, I really can't tell from this graph. So I think I'm going to go to Desmos and graph it so I can get those specific actual points. So -2 x minus 3, squared plus 5. Okay, I can click on my zeros, and it tells me my zeros are at 1.419, 0, and 4.581, 0. Okay, my vertex, since I'm here, I'm gonna just click on it. My vertex is going to be 3, 5. Also, really easy to find on my graph here. I could have just done that, but I already had Desmos up, so why not use it? Okay. Now, the last question asked us, how does the vertex of the parabola help you determine the range? So here's my vertex, and hopefully you're able to see that the y value of my vertex. So my y value of my vertex is also going to be the y value of my range. Okay? All right, and that is it. Go ahead and work on the homework problems.